Picture the sun floating in space right now. This massive ball of fire that's about 865,000 miles across. So big that you could fit over 1 million Earths inside it. And now, imagine something happens to it. Imagine gravity wins and the whole thing just collapses. And I don't mean falls apart, I mean gets crushed down smaller and smaller and smaller until this object that was almost 1 million miles wide gets compressed to the size of Manhattan, like literally the island of Manhattan. And here's where your brain should start hurting, because all that mass, everything that made up that gigantic star, is now squeezed into something you could walk across in a few hours if the gravity didn't immediately flatten you into a pancake thinner than an atom. And this isn't science fiction. This is what Oppenheimer discovered actually happens when certain stars die. And what he found out about this process, about what prevents it or doesn't prevent it, revealed something so disturbing about the nature of reality that it changed physics forever. You think the atomic bomb was the darkest thing Oppenheimer ever touched? That's what everyone thinks, because that's the story we all know. The Manhattan Project, the Trinity test, the mushroom cloud over New Mexico, the devastation at Hiroshima and Nagasaki. But years before any of that, back in 1939, when Oppenheimer was just a theoretical physicist at Berkeley playing with equations that most people couldn't even read, he stumbled onto something that made the bomb look almost quaint by comparison, because the bomb was about human choices, about what we decide to build and use. But what Oppenheimer discovered about dying stars was about the universe itself, about laws so fundamental and so merciless that nothing, and I mean absolutely nothing, can break them or bend them or escape them. And if this kind of stuff makes you realize how little we actually understand about the cosmos we're floating through, hit subscribe, because what I'm about to show you is going to make you question whether the universe even cares if we exist at all. The thing about Oppenheimer is everyone focuses on the destruction he helped create, the weapons, the fire, the death toll. But they miss the deeper story, the darker story, which is that this man spent his entire career discovering limits, boundaries in reality that can't be crossed. And once you see those limits the way he did, once you understand what the math is actually telling you about how the universe operates, you can never unsee it. And I think that knowledge, that burden of understanding just how indifferent and absolute the laws of nature really are, that's what broke something inside him long before the first atomic bomb ever detonated. Here's what you learned in school, if you learned anything about stars at all. They taught you that stars are these nuclear furnaces floating in space, fusing hydrogen into helium deep in their cores, creating light and heat through this process called nuclear fusion. And when they run out of fuel, they either fade away quietly like a dying ember, or they explode in a supernova and leave behind some kind of remnant. Maybe a white dwarf, which is like a hot dead coal the size of Earth, or a neutron star, which is way denser and stranger, or a black hole if the star was really massive. And that all sounds reasonable enough, like there's a natural progression, a life cycle that makes sense. Stars are born from clouds of gas. Stars shine for millions or billions of years. Stars die in one of several predictable ways. End of story, right? Except, here's the problem. Nobody really explained to you in school. Here's the thing that should have kept you up at night, but didn't, because they glossed over it with vague language and diagrams that hide the horror of what's actually happening. When a massive star runs out of fuel and gravity takes over, what actually stops the collapse? Like, think about this for real. Really think about it. You've got an object with 10 or 20 or 30 times the mass of the sun. We're talking about something with a mass of 4 times 10 to the 33rd grams or more. And suddenly, there's nothing pushing outward anymore. No fusion reactions creating. Radiation pressure to fight gravity, no heat expanding the outer layers. The nuclear furnace just goes dark because it's fused, everything it can fuse. And so this thing starts falling in on itself. And I'm not talking about falling slowly like a building being demolished. I'm talking about the outer layers collapsing inward at speeds up to 70,000 kilometers per second, which works out to about 43,000 miles per second. That's almost a quarter the speed of light. That's so fast that if you could watch it happen, your brain wouldn't even be able to process what you're seeing, because the scale and speed are just beyond anything human experience can reference. And all that mass is converging on the center, getting denser and denser, atoms getting crushed together, electrons getting smashed into protons, the whole structure of matter as we understand it just getting obliterated by the force of gravity. And here's where the textbook explanation gets really hand-wavy. Really suspicious in how it skips over the details. They tell you that eventually something called degeneracy pressure stops the collapse, which is this quantum mechanical effect, where particles called fermions just refuse to be in the same place at the same time because of this principle called the Pauli exclusion principle. And, okay, fine, that sounds science-y enough that most people just accept it and move on. They think, okay, quantum mechanics saves the day. There's this exotic pressure that kicks in and holds everything up. Crisis averted. But here's what they don't tell you. Here's the piece that Oppenheimer figured out, that changes everything and makes the whole story way darker. Degeneracy pressure doesn't always win. There's a limit, a hard mathematical limit that you can calculate precisely. And if a star is massive enough, if it crosses this invisible line that Oppenheimer and his student George Volkoff calculated in 1939, then nothing stops the collapse. Not degeneracy pressure, not quantum mechanics, not any known force in the universe. Gravity just wins absolutely and completely and totally. And the star collapses into something so dense and so weird that it literally breaks our understanding of space and time. It creates a singularity, a point where our equations stop working, and physics as we know it just gives up. And when Oppenheimer first worked through these equations, when he first saw what the math was telling him, I think he realized something that haunted him forever, that the universe has these built-in annihilation mechanisms, these death sentences written into the fabric of reality itself. And there's no appeal, no loophole, no clever trick that lets you escape if you're on the wrong side of the numbers. Let me walk you through what actually happens inside a dying massive star, so you can really feel why this is so insane. So you can viscerally understand what Oppenheimer was seeing in his equations. So picture you're somehow inside this star in its final moments. I know that's impossible because you'd be vaporized instantly, but just visualize it as a thought experiment. You're floating in this sea of matter that's collapsing inward, and around you, atoms are being destroyed, not broken apart. Like in a chemical reaction where bonds just rearrange, I mean completely annihilated at a fundamental level, electrons are being forced into atomic nuclei with such violence that they combine with protons to form neutrons, and this process releases these ghostly particles called neutrinos that barely interact with anything. They just stream outward through the collapsing star at the speed of light, carrying away energy. And as this happens, the matter around you is getting denser in a way that defies human intuition. Imagine being in a space the size of a city, and there's normal stellar material, hot plasma at millions of degrees, ions and electrons and radiation all mixed together. The kind of environment where, if you could somehow survive, you'd see this glowing sea of energy. Then suddenly, that same amount of matter is compressed into a space the size of a building, then a room, then a car, then a basketball, and it's still going, still collapsing. The density is climbing so fast that if you could somehow measure it, the numbers would be incomprehensible. Atoms don't exist anymore. There are no atoms. The concept of atomic structure has been completely erased. It's just a soup of neutrons packed together so tightly that a teaspoon of this stuff would weigh as much as Mount Everest. Like, literally, you could scoop out a volume the size of a sugar cube, and it would weigh more than 4 billion tons, more than all the cars in America combined, more than entire cities. Try to imagine that. Try to picture something small enough to hold in your hand, but so dense that it contains more mass than entire mountains, and your mind just can't do it. The numbers are too big, the scales are too extreme, and here's the thing that's gonna mess with your head. At this density, matter doesn't behave like matter anymore. The rules change. Neutrons are pressed together so close that they're touching. And I don't mean close together like marbles in a jar. I mean actually touching with zero space in between, pressed against each other with no gaps whatsoever. And this is where quantum mechanics says stop. This is where the Pauli exclusion principle kicks in and says no, two identical fermions can occupy the same quantum state. So you'd think, okay, this is where the collapse stops. This is the safety mechanism. This pressure from quantum mechanics should be enough to hold up even the most massive star, because it's not thermal pressure, like the heat in a normal star. It's this weird quantum pressure that comes from the fundamental nature of particles themselves. And for a while, physicists thought that was the end of the story. They thought neutron degeneracy pressure was the ultimate defense against gravitational collapse. Except Oppenheimer realized that's not true. He worked through the math with Volkoff, and they discovered that quantum mechanics has a breaking point. There's only so much weight that degeneracy pressure can support, and they calculated exactly what that limit is. If you've got a remnant core after a supernova, and it's more than about 2 to 3 times the mass of the Sun, depending on exactly how you account for rotation and other factors, then neutron degeneracy pressure isn't enough. The math doesn't work out. The pressure can't hold. And what happens then is that gravity just crushes right through this quantum mechanical barrier, like it's not even there, like it's made of tissue paper, and the collapse continues. And here's where it gets truly disturbing, where Oppenheimer's discovery becomes genuinely frightening if you really think about it. Once you cross this threshold, there is no force in the known universe that can stop what happens next. No exotic matter, no new physics, no undiscovered particle or field. The matter keeps collapsing, getting denser and denser, surpassing nuclear density, surpassing any density we can create or even properly imagine, until eventually it collapses into a point, a mathematical singularity, where density becomes infinite and the laws of physics, as we understand them, completely break down and stop making predictions. And this wasn't speculation. This wasn't Oppenheimer guessing or making philosophical arguments. This was pure mathematics. He and Volkoff solved Einstein's field equations for a collapsing star, and the math told them unambiguously, without any room for interpretation, that some stellar corpses are doomed to collapse forever with nothing to save them. No Deus ex machina, no last-minute rescue, just inevitable doom written into the structure of space-time itself. And this is where Oppenheimer realized something that haunted him for the rest of his life, something that I think bothered him even more than the bomb in some ways, because at least with the bomb there was a choice involved, there was human agency, humans chose to build it, humans chose to use it. We could, in principle, choose not to, but what he discovered about stellar collapse wasn't about choices. It was about the fundamental architecture of reality, about how the universe is actually built. At the deepest level, he discovered that the universe has built into its very fabric these points of no return, these thresholds where, if you cross them, there's no going back, no escape, no loophole, no clever trick that saves you. And the math that describes this is beautiful and terrible at the same time. You can write it down in just a few equations. The Oppenheimer-Volkoff equation that describes hydrostatic equilibrium in a static, spherically symmetric spacetime. And when you solve this equation for different masses, you find this critical threshold, this dividing line that separates two completely different fates. Stars below it can become neutron stars and survive in this weird but stable state where quantum mechanics and gravity reach an uneasy truce. Stars above it cannot. They must continue collapsing. And there's something philosophically terrifying about this because it means the universe doesn't care. The universe has rules, and if you violate them, you don't get a second chance, you don't get to negotiate or plead or find a workaround. You just fall into oblivion, and there's nothing anyone or anything can do to stop it. And Oppenheimer understood this in a way most people didn't because he could see the math. He could follow the equations from beginning to end and watch as they inexorably led to this conclusion that some things in the universe are simply doomed by their own mass, doomed before they even finish collapsing, doomed by the numbers alone, and there's no tragedy in it from the universe's perspective, no sense of loss. It's just physics playing out according to rules that were set 13.8 billion years ago when the universe began. And those rules don't care about outcomes or fairness or whether something deserves to survive. They just are. And while you're processing that reality, drop a comment telling me where you're watching from. I'm genuinely curious where in the world people are who want to understand these dark corners of physics that most folks never think about, because this stuff isn't taught in schools, it's not part of the normal curriculum, you have to go looking for it. And the fact that you're here watching this tells me you're the kind of person who wants to know how things really work, even when the answers are uncomfortable. What got to Oppenheimer was the absoluteness of it, the finality, the complete lack of mercy in the equations he'd quote from the Bhagavad Gita sometimes when he talked about physics, this ancient Sanskrit text he'd studied and even learned to read in the original language because he was fascinated by Hindu philosophy. And there's this concept in it about cosmic inevitability, about how certain processes once started cannot be stopped, how the universe unfolds according to laws that transcend human understanding or control, and I think when he looked at his equations for stellar collapse, he saw that same inevitability written in the language of mathematics. He saw that if you're a star of a certain mass, you're essentially predetermined to end in total gravitational collapse the moment you're born, that your fate is sealed not by anything you do, but by what you are, by your mass, and there's something deeply unsettling about that when you really think about it, this idea that mass alone can doom you, that there's a number, a specific calculable number, beyond which the universe just gives up on you and lets gravity have its way. And it doesn't matter if you're a star or a person or a civilization. The principle is the same. Cross certain thresholds and there's no coming back. And Oppenheimer spent his whole life discovering where those thresholds are. And here's what made it worse for Oppenheimer. Here's what really disturbed him when he followed the math all the way through. When you see what happens to space-time itself as one of these doomed stars collapses past the point of no return, when you watch the geometry of reality warp and twist under the influence of all that concentrated mass, you discover that it creates a region where the curvature of space-time becomes so extreme that not even light can escape. We call them black holes now. But Oppenheimer didn't have that term yet. The phrase wouldn't be coined until 1967 by John Wheeler. Oppenheimer just had the equations telling him that space could fold in on itself so completely that it would create a one-way membrane in reality. A surface in space-time that once crossed means you can never come back. Ever. Not even in principle. not even if you had infinite energy and infinite time. The geometry of the universe itself forbids it, and the math was clear. Unambiguous. It said, this must happen if you have enough mass in a small enough volume. It wasn't optional, it wasn't unlikely, it was inevitable, guaranteed by the same equations that describe how planets orbit stars and how light bends near the sun. And Oppenheimer realized this in 1939, right on the eve of World War II, years before anyone took the idea seriously, decades before we had any observational evidence that black holes actually exist. He just saw it in the equations. And knew it had to be true, because the math doesn't lie. Mathematics is the language the universe speaks, and when it tells you something, you better listen. The paper he published with Volkoff titled On Massive Neutron Cores came out in February of 1939, and then, a few months later in September, he published another paper with his student Hartland Snyder about what happens when a star continues collapsing past the neutron star phase, and in that paper, they showed that from the perspective of an outside observer, the surface of the collapsing star appears to freeze at what we now call the event horizon, the light from it getting redder and redder and dimmer, but never quite winking out. While from the perspective of someone falling with the collapse, they just sail right through that invisible boundary and keep falling toward the singularity at the center. And there's no sensation of crossing it. No warning. You just pass the point of no return without even knowing it until you try to send a signal back out and realize that's impossible now. You're trapped in a region of space-time from which no information can ever escape. And Oppenheimer's equations described all of this in exquisite mathematical detail years before most physicists even believed such things could exist. And I think what disturbed him was not just that the universe allows this to happen, but that it's mandatory. That if you meet the conditions, the universe doesn't give you a choice, it just does this to you. It traps you behind an event horizon and crushes you into a singularity, and there's nothing you can do about it because you're not fighting a thing. You're fighting the geometry of space-time itself, and you can't win that fight. Nobody can, not even in principle. So next time you look up at the stars, those tiny points of light scattered across the night sky, billions and billions of them spread across billions of light years. Remember that some of them are already doomed. Their mass has already sealed their fate. Even if they're still shining brightly now, they're going to collapse someday. And there's nothing that can save them, because they're on the wrong side of a mathematical limit that Oppenheimer calculated over 80 years ago. And that limit doesn't care about anything. It doesn't care if the star has planets, doesn't care if those planets have life, doesn't care about the billions of years that stars spent fusing hydrogen and creating light and warmth. It's just numbers, pure physics, and it's absolutely merciless. And the same forces that will eventually crush those stars into singularities are the forces that hold your body together right now. Gravity trying to pull every atom in your body toward every other atom. Electromagnetic forces keeping your electrons from crashing into your nuclei, the strong nuclear force binding protons and neutrons together despite their electromagnetic repulsion. Quantum mechanics creating the pressure that gives matter its apparent solidity. All these forces locked in this eternal tug-of-war. And for you, for Earth, for the solar system, the forces resisting gravity are winning. We're stable. We're safe. We're on the comfortable side of the threshold where quantum mechanics and electromagnetism are strong enough to resist gravitational collapse. But Oppenheimer showed that's not guaranteed, it's not a given. It's not something the universe owes you, it's just a consequence of having the right amount of mass in the right configuration. Change those numbers and everything changes, Add enough mass and gravity wins, and nothing can stop the collapse. And in a universe with no inherent meaning or purpose or design, where we're just patterns of matter temporarily organized into something that can think and feel and wonder about its own existence, where consciousness is an accidental byproduct of chemistry, which is itself an accidental byproduct of physics. The fact that we happen to exist in a stable configuration rather than collapsing into oblivion is nothing more than cosmic accident, statistical luck, in a universe that generates every possible outcome given enough space and time. And I think that's what really disturbed Oppenheimer. Not that bad things happen in the universe, not even that we built weapons capable of incredible destruction, but that the universe doesn't distinguish between good and bad, between creation and destruction, between life and death. It just follows its rules with perfect consistency. Stars collapse when they exceed a certain mass. Atoms split when struck by neutrons of the right energy. Humans build weapons when they discover the underlying principles, and none of it means anything beyond the physics and the mathematics. There's no cosmic justice, no balancing force, no universe that cares about outcomes, just particles and fields and forces playing out their interactions according to laws that were set at the beginning of time in the first moments of the Big Bang. And those laws don't care if we understand them or fear them or try to work around them. They just are, eternal and absolute and completely indifferent to our existence, to our hopes and dreams and civilizations. They'd operate exactly the same if we'd never evolved, if Earth had never formed, if the universe contained no life anywhere. The math would still work out the same. The limits would still be in the same place. Stars massive enough would still collapse into black holes. Matter would still organize itself according to the same quantum mechanical principles. And there'd be nobody around to know about it or care, which makes you wonder if our existence actually matters in any cosmic sense, or if we're just transient patterns in a meaningless universe, temporary organizations of matter that happen to be complex enough to ask questions about our own significance and find no satisfying answers. Can you accept a universe that operates that way, where your survival is just luck, where intelligence and consciousness aren't special or protected but just happen to exist in certain configurations of matter under certain conditions, where the same rules that let stars shine also guarantee that some of them will die in the most violent way possible, where consciousness and love and art and science and everything we value could just as easily have never existed if the initial conditions had been slightly different, if our particular patch of matter had been part of a star massive enough to cross Oppenheimer's limit, instead of becoming a planetary system with stable conditions for billions of years, if the carbon and oxygen and nitrogen that make up our bodies had been trapped behind an event horizon instead of scattered into space to eventually form new stars and planets, and us? If this video made you see the cosmos differently, made you realize how strange and terrifying and beautiful it is that we're here at all, that we exist in defiance of entropy and chaos, that we're temporary islands of order in an ocean of randomness, smash that like button. So I know this stuff resonates with people, and if you want to keep exploring these dark revelations about how reality actually works beneath the comfortable illusions we live with every day, hit subscribe and turn on notifications, because I'm diving deeper into Oppenheimer's discoveries every week, exploring the limits he found and what they mean for how we understand ourselves and our place in the universe, and comment which aspect of stellar death you want me to explore next, whether it's the internal structure of neutron stars and what matter actually does at nuclear densities, or the mathematics of black hole formation, and what happens to information that falls past the event horizon, or what conditions lead to supernova explosions versus quiet collapse. Let me know what mysteries you want to unravel together. What questions keep you up at night when you think about how vast and strange the universe really is? Thanks for watching.